Yeah. So, good evening. In today's session, I'm going to explain linked list data structure. Okay, linked list data structure in Python. So, actually, we can implement this linked list concept by using any programming language. So, here I am going to take Python implementation to demonstrate various operations that we can able to perform on linked list. First of all, so what is mean by linked list? So very simple, the basic definition here is collection. Collection of nodes is called as linked list. Collection of nodes is called as linked list. So node means so which can able to hold data. There are two types of nodes are there. The first one is single node and second one is nothing but double node. So what is mean by single node in the sense where it is having two fields. One is nothing but data field and second one is nothing but next field. Okay, next field pointing to the next node. And if you take double node, it is going to associated with three fields. One is a data field and another one is nothing but next, which is pointing to the next node, and another one is nothing but previous, which is pointing to the previous. So next is to next node, previous means previous node, like that we have. So but once if you see the diagrammatic representation, then only you can able to understand what is mean by this linked list. Very simple. In a simple format, I can represent a structure of the node like this. How many fields I am going to take? Two fields. This field is called as what? Data field. And this field is called as what? Next field. Okay, similar to this, if you take a node like this with two pointers, in the middle I'm going to take the pointer as a data, and this field is called as what? Previous field, which is representing the previous node, and this field is called as what? Next node, which is pointing to the next field. So you can collect them like this. You can collect list of nodes in this style. Assume, just for example, I am taking these nodes are single linked list. So data is 10, next field is pointing to the next node, and data is 20, this field is pointing to the next node, data is 30, there is no next node to 30, it is represented as a none. And how to identify these nodes? The first node is always labeled with a special pointer called as what? Head. So today we are going to see practically how to implement this linked list data structure. Okay, so I'm going to explain by using two tools. One is Jupyter Notebook and second one is I'm taking a Python program manually by using object oriented programming concept. So to demonstrate this, compulsory you should have an idea about object oriented programming. If not, maybe introduction part of 2 I will provide. Wherever it required, I will give the information. Are you clear with this concept? Up to this introduction, whatever I have given, is it clear? Yes, please confirm everyone.
Yes, sir.
Yes, please confirm everyone. Right. So now I'm going to use this Jupyter Notebook to demonstrate this. So for this, already Anaconda Navigator is installed in my system. Let us open that. So it takes some time. Please wait.
Sir, why we cannot use linked list as linked list to in random access, sir?
It is a random access. See, we have list data structure is there, right, in Python.
Right, sir.
In the same way, linked list is also there. So, but actually before Python, if you take any other languages, there one concept is there with name arrays. Do you
Yes,
know
sir.
arrays?
Yes, sir. Yes, sir.
There is some problem is there in the arrays. That's why if you want to store huge volume of data, array.
Contiguous memory.
So that is the reason why we are going for linked list. Got it?
No, sir. Kindly explain once again.
Yeah, in arrays we are going to hold only limited storage data. I mean, you can suppose if you want to store 10 items, you have to create an array to store only 10 items. During execution of the program, if you want to store 11th item, it won't accept. So to overcome that problem, not only Java people, in every programming language, so we can go for this linked list concept, where it is a dynamic memory allocation it will provide, and by using pointers we are going to implement. So random access will be there, okay, but we can able to store huge volume of data in that. So it is nothing but collecting the data, beyond that nothing. Okay,
Now got it, sir.
right. But here in Python, of course, we have already list concept is there. Internally, it is implemented by using linked list only. Okay, so that's why we are not going in depth into that. But since we have a topic is there in Java, I mean in data structures, I'm demonstrating this by using linked list. I mean by using this object-oriented programming. Got it?
Yes, sir.
Right. Now I'm creating here, this is the Jupyter lab actually. Here you can able to practice the programs. So once if you select a new notebook, it will be, it will look like this. Here you can execute the scripts. Here one box is there, right? Here you have to type the content, and if you press run, automatically it is going to execute. Just for our convenient, let us print a message saying, so good evening, something like this I am printing. If you run the code, what will happen? It is going to print the message called good evening. That's all. It is something like, if you want to execute scripts, then we can go for this Jupyter notebook also. This is one of the tool what we have. So now I want to create the structure of node. I told, right, if I want to implement a single linked list or double linked list, okay, so you need to create a node. So what is the content of the node? Since I am talking about a single linked list, I am going to create a node. For that, I am taking a class node. So inside this, I am defining a constructor, so which is going to take a self comma data. So self dot data is equal to the data I am assigning. So self dot next is equal to I am taking none. This is nothing but the structure what we have to represent a node. Okay. Here if you see what content is there, sir, once if you create any object for node, it will be created like this. Okay. So how many fields are there? Two fields are there. One is nothing but data, another one is nothing but next. So I'm giving this one as the data, this one is nothing but next. So since we are using object oriented programming, we have to use self dot data. Since we are using object oriented programming, since it is related to the node class, it is called as next pointer. Like this, two fields will be there. I created an object structure which is nothing but node, yeah, Priyanka, correct. So the constructor name must be always
Underscore init underscore. Sir.
underscore, like this we have to take. Once if you run this, there won't be any output, because just we created one template for node. Okay, just we created one template for node. But once if you create the object, how it will be, I will demonstrate by taking the example. I will explain. Now consider I'm going to take, so one new node I'm going to create. Okay, so consider n1 is equal to, I'm creating a node, I'm passing 10 as the input. So now what will happen? A new node will be created. If you want, you can print the content. How to print? N1 dot data I'm printing, which will print 10, and N1 dot next field I am printing. Sir, is there any content to the next field? No, right? That's why it is going to print empty. Sir, now this is nothing but the node what we have, and this node name is nothing but what? N1. The data field is nothing but 10. So next field is, as of now there is no next field, that's why it is pointing to none. So if you create n1, a node will be created in this style. You are printing n1 node data. What is the n1 node data here? 10. So I am printing n1 node next field. Is n1 node next field is pointing to anything? No, that's why it is going to return none. So if you want, just run this code, you can see 10 and then none, like this we are getting. So continuation for this, n2 is equal to, okay, n2 is equal to, I am taking node of 20, node of 20. Now I am printing n2 dot data. What output we will get? 20. So I want to print n2 dot next. So what output we will get? None. Like this we are going to get. Now observe carefully. Sir, we are creating another node. Okay, we are creating another node. So what is the name of that node? n2. So what is the content? 20. What about the next field? It is pointing to empty. That's why it is none. Even if you run the code, you will get like that. So here equal to symbol we have to take, sorry, 20 and then none. Sir, now I want to link these two. How to link these two? Very simple. N1 dot next is equal to, I am going to take N2. Sir, what is the meaning of this line? So N1 is there, right? It's a next field I am going to link to. Okay, this next field I am linking to, sir, which node? N2. So N1 next field is pointing to n2. Now these two nodes are attached with each other. Okay, these two nodes are attached with each other. How to print n1 data? Sir, can I take n1 dot data, which will print 10? Sir, I want to get the data of n2, but I don't want to take n2 name. How to print that? Sir, can I take n1 dot next? So n1 is pointing to 10. n1 dot next means it is pointing to 20. It's a data I want. Sir, definitely it is going to print which value? 20. If you want, just you can cross check. We are getting 10, 20. Okay, like that we can able to create any number of nodes, and slowly we can able to attach the nodes. Okay, sir, are you clear with this? Please confirm.
Yes, sir.
Just a basic terminology I explained. Any doubt up to this? Friends, please confirm. Clear?
Sir, why you are using class in this linked list implementation? Why? Because apart from, means I want to say that without class can we implement linked list?
Sir, see, why I am taking this class means, you can see, in the diagram itself I am representing how many fields? Two fields, right?
Yes.
In the outline, if you see, it is a single object. Am I right?
Yes, sir.
So single object contain how many fields? Two
Two.
fields. Like that, do we have any data type in Python? Because if you take 10, which can hold only integer, there is no next field. If you take floating point, there is no next field. So all these are individual objects. Okay, that's why I am creating my own representation for that user defined data type. This is also
like structure in C.
Abstract data type. We are creating our own data type, which can able to hold data field next field. Got it?
Like we are having structure in C.
Yes, yes, same step.
No, got it, sir.
Got it?
Yes, sir.
Right. So now So I told already, whenever we are creating a linked list, there will be a special pointer will be there with name head. Head is equal to, I am taking node of 222. Okay. Now, sir, print of head dot data I am printing. Which data it will print? Sir, what is the head node content that we have? 322. Otherwise, let us take 311. So what is the content that we are going to get? 311. Now, what is the head dot next field? Since it is not created, it is pointing to none. Like this we have. Now, head dot next is equal to, I am creating a new node with content 312. Now, if you take head dot data, what is the data that we are going to get? 311. So now I am taking head dot next dot data. What output we will get? 322. If you want, you can see. Sir, practically what is happening here? We created, okay, better I will go with another diagram. Yeah, you can see. So I have a pointer, I mean, yeah, I have a node is there like this. Okay, a node is there like this. You can see the content is nothing but what? Sir, this is nothing but I will create a backup for this. Okay, so here the content is initially 311. The content is initially, so 311. What is the name of this node? I have given the name of this node as which node? Head node. Head node is always pointing to this beginning. Sir, this is nothing but the first line what we have here. Head is equal to node. Head dot next is equal to node means what? We are going to create another node like this. We are creating another node like this. Sir, where the content is nothing but 322. Content is nothing but 322. And this field next node is pointing to this one. Okay. So like that, I want to create one more node. Like that, I want to create one more node. Like that, I want to create one more node. Sir, now we have to link each and every node like this. So this field will become, so 333, and this field will become, so 344. This field will become 355. Like this we have. Now, what about next last node? It is pointing to none. How many nodes are there in the linked list? Total 5 nodes are there. As you can see here, head is equal to node of 311. Head dot next I created. Now I want to take head dot next is equal to node of 333. Okay. Next head dot next will become, so node of 344. So now head dot next, so dot next field will become, I am taking node of 355. Like this I am creating. So we created a linked list. If you print head dot data, what output we will get? 311. If you print, so head dot data, sorry, head dot next dot data, what output we will get? 312. If you print head dot next dot data, we will get 333. If you print head dot next dot data, we will get 344. So print of head dot next dot data, we will get 355, because these links already we created. If you want, you can check. So from this diagram, you can see by using only one pointer, how many fields we created. Okay. I think you people got some idea how to represent the linked list. Any doubt? Yes, please confirm. Clear?
Sir, next, what is this?
Next, from the diagram, you can see. So every node is associated with two fields, right? One is the data field, another one is next field. Am I right?
Yes, sir, yes.
Data field I am giving as, you can see here, the data field I am giving as 322. What about next field? So head dot next, that means head node is there. Its next field is pointing to a new node with data 322. What about next field? In the class itself, I have written next field is always none. Okay, so it will create a new node with the content 111. Next field is none. Then this is the head node. For that next node, we have to attach. How to attach? What is the name of this 222? As of now, I am not giving any name. Can I represent like head next node? Yes, that's what I am giving here. So head dot next is equal to a new node of 222. Its data is 222. Next field is none. That's why head dot next. Head represent which node? 311. Head dot next represent which node? 322. So dot next is equal to 333. That means what? This node we are creating. Like that, a chain of nodes we can create. Of course, actually it is the raw way I'm explaining, but we will see in detail. There is one method is there. So by using that method, happily we can add the content to the linked list. That part I will explain.
Actually, head dot next should hold the address of the next object, right?
Yes.
How it will hold the data?
Sir, here we have given, right, in the structure itself we have given. Actually, if you see, class node is there, right?
Yeah,
So
yes.
dot data is equal to data. Whatever data you are giving, so that will be pointing to this current node data. And the next field is always represented as none. That means no value associated. Am I right? Here, if you see, I'm writing like this: head dot next is equal to none. Initially, this is the head. Head will become which node? 11. Initially, head will become 311. Head dot next value is what? Head dot next value is what? None, right?
Yes.
Now, what I am doing is I created another node. Let it be n1. Head dot next is equal to I am taking n1. N1 is what type of data? Is it node type or not?
Yes. Yes.
So now head dot next is pointing to another node like this physically. Got it?
Oh,
Right. Sir, clear everyone? Please confirm.
Yes.
Sir, I have a doubt, sir. Hello?
Please tell me.
Sir, we have to write always the head dot next. It's so massive, sir. Another thing I have to write in that.
At the top level, we have some special method is there. By using that, directly we can add an node into the linked list. We are not required to use this continuously.
Okay, sir.
I will
Thank
explain.
you, sir. Thank you, sir.
Right. So if I want to display the content present in the linked list, as you can see, I have taken like this: head dot data, head dot next dot data, head dot next dot next dot data. Like that, keep on I am writing. I don't want to do like this. Simply, I want to define one function called display, displaying elements, displaying the content of nodes. So present in single linked list. So I have a single linked list is there. In that, some nodes are already attached. I want to display the content. So I'm going to define a function for this. The function name is nothing but a print list. So you have to pass a head. Okay, you have to pass the head as the parameter. Now this function is going to print each and every content. So first it is going to take temp is equal to head. I am marking in the red color. Please have a look once. So initially, this is my linked list. What I have, right? Yes, this is the linked list. Now I am going to take, so temp is equal to head. That means initially my temporary node is pointing at which location? This head location. Am I right? So temp is equal to head. After that, what we are going to do is temp is equal to none or not? I am checking. If temp is equal to none, then what is the meaning? Can I say linked list is empty? Okay, linked list is empty. We don't have any elements, simply written. Sir, is the temp value is equal to null? No, because it is already having some content. So it is having a node. That's why it is not none. Then what we are going to do? We are going to write a while loop until this temporary field is not equal to none. Can you please print temp dot data and end is equal to, just I am giving some arrow mark. So after that, temp is equal to temp dot next I am taking. At last I will print the value called none. So now see what is happening here. So temp is equal to initially head we assigned. Sir, is that head is pointing to none? No, because content is there. Then is a temp is not equal to none? Yes, it is not equal to none. Then what will happen? We are printing that data. So what is the data that we have, sir? 311. After that, it is giving some arrow mark. So now what is happening? Temp is equal to temp dot next. Sir, can I say, is it my temporary node beginning? Now I am going to take this one as the temporary node because temp next node is 222 only. Now while loop is going to check, is it equal to none? No, it will print the data and arrow mark. So temp dot next, what is a temp dot next? This one will become temp dot next. Is it equal to none? No. Then it will print the data called 333 and it is going to give arrow mark. So what is the next node for this? This one. Is it equal to none? No. It will print the data and transfer the control. So next one is 355. Is it none? No. It will print the data. So next one, sir, is there any node to the next to temp? No, because temp is pointing to none. Then immediately it is going to print the content saying none. This is the way how you can able to do. Okay, now I am going to run this code. So there is no mistake. Since it is a function, I am calling print list by passing head. Only one function is sufficient. Simply I am passing this head. Automatically it is going to print each and every content. Sir, is 311 is there? Yes. 322 is there? Yes. 333 is there? Yes. Every element is available. So this is the way first function I explained how to print the elements present in the linked list. If the linked list is empty, then what will happen? It is going to print linked list is empty and it will return the control. Okay. So how the flow of control is happening along with the diagram I explained. Any doubt, friends, up to this?
No, sir.
Is the concept is clear? Now, so I am demonstrating one more operation on this. So this is somewhat difficult to understand. So please focus. So this is the linked list what I have. My requirement is I want to add. So I have another new node is there. Okay. I have another new node is there. My requirement is I want to add this node at the beginning. Okay. I want to add this node at the beginning. So consider the data of this node is nothing but something like 666. Okay. Like this, I have a node. Next field is pointing to none. So this node name I am taking as a temporary node. I want to attach this node into the linked list at which position? First location. So for that I am writing a function. The name of the function is nothing but insert a new node at first location in the linked list. Sir, how to do that? I am defining a function called insert at first. Okay, so insert at first, where I am going to pass head node at the same time data field. Both I am going to pass. So temp is equal to I am creating a new node with the given data. So then temp dot next is equal to head, and then we are going to return the temp. Now see what will happen. Only 3 lines of code. So I'm going to create a new node. Yes, my new node is available. What is a new node name that I have given? Temp. Temp is equal to node of data. Now temp dot next is equal to what? Head. So temp dot next. This is the temporary node, right? Its next field is pointing to head node. So we can able to remove this next, and this one is pointing to next node. What is the next node to this? Head. We are returning this temp. So automatically this will become your head. How this will become your head? I will write the code for that. Listen carefully. So this will become our head. Sir, how it is going to work? At the time of calling, I am going to take like this. So if you print, okay, if you print a list of head, what will be the output? You can see 111, 222 like this we have. So for this, I am going to call insert at first. Insert at first. So for the head node, I want to add what is the object that we have given 666. I want to add a new node. The content is nothing but 666. So to which node we have to add head node? So that should be inserted at the first location. And it is going to return the newly created node. That newly created node I am assigning to the head. That's all. So after this, if you print list of head, you can see which object you inserted that came to the beginning, sir. Okay, this is the procedure how to insert a new node to the first location in the linked list. Any doubts?
No, sir.
Clear, right? How it is functioning? Is it clear, right? Right. Sir, in the same way, I want to add a new node at the end of the linked list. So consider this is my linked list. I want to add a new node. Assume the content of that node is nothing but something like 888. Okay, I want to add a new node. What is the content? 888. 888 is the content. So next field is initially null, and this is the new node, right? I am taking the name of the new node as NN. NN represent which node? New node. Now my requirement is I have to attach this new node at the end of the linked list. And we need to connect these two nodes. Which two nodes? 555 and 888. How to connect that? We will write code for that. So now I'm going to write insert at last location. I'm taking the function name like insert at last. So head pointer must be required. Data is also needed. So I'm going to check, is your head is equal to none? If head is equal to none, first we have to create a new node, right? So new node is equal to, I'm taking node of the given data. So we are going to call by passing the data as a 888. So it created a new node. What is the name of that new node? New node I have taken like this. Okay. So next and after that, I'm checking is head is equal to, okay, is head is equal to none. If head is equal to none, then what is the meaning? We don't have any elements in the linked list. Then, sir, whatever element that you inserted, okay, whatever element that you created, it will become head node, right? Because if there is no nodes, so directly I'm going to take, if head is double equal to none, simply I'm going to take head is equal to new node and we have to return that head. But in this scenario, head is already there. Okay, we have to attach this node. How to attach that node? Very simple. Current node. Okay, current node is equal to, I am taking head. So where head is pointing 666, right? This node will become which node? Current node. CN, current node. Now observe carefully. CN is equal to head. I am going to check is, so that current node dot next field is not equal to none. Sir, what is the current node? 666. Is next field is not equal to none? Yes, its next field is not equal to none. Then what I am doing is current node will become current node dot next. So immediately what will happen? Now this is not current node. This will become current node. Since it is a while loop, again it is going to check. Is current node next field is not equal to null? This is the current node. Next field is 322, which is not equal to none. So current node will come here. Is it next field is not equal to none? Yes. Current node will come here. Is its next field is not equal to none? Yes. Current node will come here. Is its next field is not equal to none? Yes. Current node will come here. Is its next field is equal to none? Have you observed n is there? It is equal to none. It will stop. That means we came to this position. We have a name of this node. We have a name of this node. These two nodes we have to connect now, right? So I will come out from the while. Then I'm going to take, so current node is there, right? Its next field is pointing to new node. So current node next field is pointing to new node, and I am going to return that head. So current node is nothing but a 555. Its next node is previously null. Now it is pointing to this particular node. Okay, and we are going to return this head so that the total list will become like this. If you want, I will execute this program. You can see previously, if you print the list by passing head, what output we are going to get? 666, 111, 222, 333, 344, 355. Now head is equal to, I am calling insert at last to the head node, and I am going to pass the object. Which object we are trying to insert? 888. That's all. Automatically it is going to insert. Sir, after that, can you please call print list of head? Definitely that element should be there at the ending. Previously 888 is not there. Now 888 got inserted at last location. Sir, are you clear with this approach? Please confirm everyone. Clear?
Yes, yes, sir.
Sir, everyone feeling comfortable up to this, whatever I covered?
Yes, sir. Sir, can we convert linked list to list so that it would be easy for appending element in first position or last position?
Uh, why, sir? Because you are telling that predefined methods will be there.
No, sir. I'm asking that can we convert? Yes, sir. In list we are having a predefined function, but not in a linked list. That is why I'm asking.
That is the work which we are doing. How that insert, append function, insert function is going to work, I am demonstrating by use manually.
Got it. Yes.
So how internally these functionalities are working, I am demonstrating.
Means, sir, internally this type of code has been written for that insert method or that libraries which are there. That code internally, this code has been written for that, right?
See, if you take L is equal to 1, 2, 3. Okay. If you print the list, what output you will get? 1, 2, 3. Now L dot append of something like 999. So after that, if you print list, what will happen? It is going to print that 999 is added at the end, right?
Yeah.
Same thing, how they have written code for append, like this will be there. Got it?
Correct.
Got it.
But see, it is a sample I am explaining. Still another 2 classes are there. There you will get a complete overview of the picture. Okay.
It's just a trailer.
We are at very beginning stage. Try to understand the functions and the flow of execution. How the links are attached, how we are going to detach the links, how we are returning the data. Those things, please focus. Okay. Up to this, no doubts, right? Please confirm everyone. Can I go for next functionality?
Yes, sir.
Right. Now see, I have this linked list is there. Assume it is a fresh linked list. So into this linked list, I want to add one object. So in which position? Sir, maybe I want to add the object. I want to add the object. That object is nothing but, so like this. This is nothing but a new node. I want to attach this new node. The new node content is nothing but 999. The name of this node is nothing but, let it be new node only. I want to attach this node in between these two. That means what? In between this 333 and 444, I want to insert. Sir, now for this we have to give the location. This is 0th location. Okay, this is 0th location, first location, or you can consider it as a first location, second location, third, or anyway we are counting from 0, right? Let us take 0, 1, 2, 3. Okay, so 4, 5, 6, like this we have. Now I want to insert this node into which location? I want to insert this node at 4th location. Means what? In the place of 444, 999 will come. Sir, don't feel that 444 is going to be removed. In between this, it is going to attach every node is going to move ahead. Why? Because we are not breaking the links. Now we will see how to implement this code. It is very simple. Insert at first means only single line code. Insert at last means we are taking a pointer and we will ask that pointer to point to the till end, and then we are adding. Now we have to stop at this stage. How to stop at this stage? We have input is there, right? Based on that we can stop. Sir, if the outline is clear, I will implement this program. Is the outline is clear?
Yes, sir.
Yes, sir.
Please confirm. Right. So now I will implement the program. Let us have a look once. So I'm going to take, so insert at a specified location. Sir, how to insert? For this I am taking insert at location. Anyway, head is mandatory because to which linked list you have to add, that is mandatory. And I am giving location also, and I am giving data. Sir, first I am going to create a new node is equal to node of data. I think in the diagram already I created that. Yes, my node is ready with content 999. So after this, what we are doing, sir, I am going to check is the location is equal to 0. Can you please tell me if location is equal to 0, sir, which case it is? In which position we have to add? Yes, if location is equal to 0, can I say is it insertion at first location? Please confirm.
Yes, sir.
So then already we have a code for that. Just we need to run that code. What is that code? New node dot next field will become head, and then we have to return new node. Have you observed? So 2 lines of code. So new node dot next will become head node, return the new node. That's all. Sir, if location is not equal to 0, sir, location is not equal to 0, then what we are doing as usual, our current node story. Okay. So current node will become, I am taking current node will become, I am taking head node. So which one will become current node? I am marking in the red color. Sir, this one will become current node. Excellent. Sir, now we have to bring this current node up to which location? Third location. So that we have a name of this node. We have a name of this node. You can bring that here. Okay. So current node is nothing but this one. Okay, fine. Then index is equal to 0 or location is equal to 0. Based on these two, I will write a condition. What is the condition? Current dot next is not equal to none and I less than location minus 1. So till that, I am going to take current node is equal to current dot not next, I is equal to I plus 1. Observe this loop. So current node next is not equal to none. Yes, current node next is not equal to none. One more condition is there. Is I is less than location minus 1? I is equal to initially 0. Is it less than location minus 1? Yes, condition is true. Then what will happen? Current node will become current node dot next. So current node will become current node dot next. Then this value is incremented by 1 unit. Sir, is current node next field is not equal to none? Yes. So now what will happen? Is it less than 3? Yes. Then current node will become current. Sir, now is current node next field is not equal to none? Yes. So then what about I value? 2 less than 3, condition 2. Then current node will become current node dot next. Is next field is not equal to none? Yes. Sir, this location is less than 3, condition false. So it will stop here. Sir, how this current pointer came here? Is it clear for you people? Please confirm. Sir, please confirm. Clear? Right. So after coming out from this, what we have to do? Sir, your current node is there, right? Your new node is there, right? Sir, its next field will become current node next field. Okay, so I'm writing code like your new node next field will become, so current node next field means what? So this is nothing but a new node, its next field will become current node next field, like this we have. So after this, current node next field will become new node. Okay, so current node next field will become which node? New node. Like this I am taking, that's all. At last you have to return head. Sir, now run the code. Perfectly it is working. Try to print the list initially. This is the list. So now head is equal to, I am calling insert at a location. Insert at a location. I am giving head pointer and then 999. Let us insert at third location. After that, I am going to print list of head. So now you can see where it is added. Sir, is the term, sorry, here I think we have done mismatch, sir. So first we have to give the location and then data. Sorry, by mistake I added this 3. No problem, you can see. Sir, what is happened? Is that 999 added at third location or not? You can check, it is added at third location. Okay, sir, clear up to this? Please confirm. Sir, clear up to this? Please confirm.
Yes, yes.
Right.
Yes, sir.
Yeah. So just please wait for 5 minutes. I will be back. Please wait for 5 minutes. Yeah, right. Let me continue. Sir, am I audible? Please confirm.
Yes, sir.
Right. So as of now, I covered totally 4 modules in this. The first one is creation of a node class. So we are talking about single linked list. In this single linked list, we have seen how to create a node class. Next and after that, print list function, how to print elements present in the linked list. Next and after that, insert at first location. So how to add the element at first location we have seen. Okay. So next and after that, we covered insert at a last location and insert at a specified or given location. Are you clear with these 4 functions, whatever we discussed? Please confirm.
Sir, one more.
Yes.
Sir, like how we are performing operations in list, like ascending or descending order, can we do the same operations in the single linked list and double linked list also? Is it possible, sir? Sir, we are performing operations like on list, like arranging the elements in ascending order and descending order. Is that
Actually,
possible? Yeah, is
actually,
that possible? Is that possible in single list also?
not all operations we can perform, sir. We can perform only operations. I will. What are those operations?
Okay.
Because directly, see, if a list, what is the advantage of linked list? You can have 100 objects, right? So is it possible to sort those 100 objects directly? Because location, such type of things are not there. Only one pointer will be there. What is the name of that pointer? Head. By using this pointer, how you can compare? So you can compare 2 nodes, but how to compare remaining nodes? It is not possible. Okay. I will explain how you can able to resolve that. Clear?
Okay, sir. Okay.
Sir, is everything is clear? Please confirm. Right. So next operation, I want to count how many elements are there in the linked list. So I think it is very simple. So counting, okay, counting. So number of nodes, how many nodes are there? I want to count. So count of, I am taking head. Okay. So count is equal to 0. I am taking current node is equal to head. So as usual, we know the loop, right? Until the current is not equal to none, we are going to take count is equal to count plus 1, and the current will become current dot next. At last, we are going to return current. So how to call this? Just I am going to print. So count of, I am going to pass the head node, which is going to return how many nodes are there. Here you can see 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9 elements are there. But how it is working in the background, you can see. Sir, initially, I am marking with some other color. So initially, the value of count is equal to 0. Initially, the value of count is equal to 0. And the current is equal to head. So which is a current node now? This is nothing but a current node. Sir, I am not checking the next node. I am checking the current node itself, because next node is always checking the next node. But we have to count this one also, right? Is current is not equal to none? Yes, sir. Then count will become count plus 1. After that, what we are doing? Current is equal to current dot next. Sir, now what we are doing? Your current will become here. Is it not equal to none? Yes, sir. Then count will become 2. So current is equal to current dot next. Is it not equal to none? Yes, 3. So current is equal to current dot next. Is it not equal to none? Yes. Current is equal to current dot next. Is it not equal to none? Yes. Current is equal to current dot next. Is it not equal to none? Yes. So current is equal to current dot next. Is it not equal to none? Yes. So current is equal to current dot next. Is it equal to none? Yes. Then it will stop. How many nodes are there? 7 nodes are there. Like this, it is going to return how many nodes are there. Okay. Are you clear with this count function? Please confirm. Yes, please confirm everyone. Right. So next, I want to find out the middle element present in the linked list. Okay. So middle element in the linked list. How you can find out middle element in the linked list? So I am taking DEF. So middle element, something like this. So where it is going to take a head. In addition to count, I am going to take a total how many elements are there. So in this example, if you see total how many elements are there? Sir, count is equal to 0. The number of elements will become 7. We have to return middle element. Sir, very simple. The process is the same like whatever we have done in the previous case. While current is equal to head, is count value is less than n by 2. I am checking. If the condition is true, count is equal to count plus 1 and your current will become current dot next. This process is going to be continued. At last, we are going to return that current node dot data. Okay. Now have a look once. Here count is equal to 0 initially. So n is equal to how many elements are there? 7 elements are there. So is count is less than n by 2. So is 0 is less than n by 2 means 7 by 2, which it is going to return 3. Sir, is the condition is true? Yes. Then what will happen? Count is equal to count plus 1 and current will become current plus 1. This is the current node. Now this will become current. Is current node is none? No. And is count value is less than 3? Yes, sir. Then this value will be incremented by 1 unit. This count will move here. Is count is not equal to none? Yes, sir. So then count will become, is count is not equal to none? Yes, sir. Sir, is that value is less than this one? Yes. Then what will happen? Your count will become here. Sir, now this count value will be incremented. Is count is less than 3? Condition not satisfied. So it will return current node data. 333 is nothing but the middle element. Is it correct? First element, last element, second element, second last, third element, third last. This is the middle element. Like that it is going to return. So if you want, you can call. So first I will print the list here. Okay. After that print of. So middle of head I am taking. Now run the code. So middle element, the function name I have taken in the wrong way. You can see. So 1, 2, 3, 4, 5, 6, 7, 8, 9 elements are there. Middle element is 333. Okay. Like that we can calculate counting of nodes. Next and after that middle element in so single linked list. Okay. Are you clear with this? Please confirm.
Yes, sir.
Any doubts up to this? Please confirm. Right. So next operation, I want to search for the element. Okay. So I want to search for an element in the linked list. I am going to perform which operation? Search operation. How to search for the element? Sir, it is also by using this current node pointer, right? Search operation in linked list. How to do that? DEF I am taking. So search 1, where I am going to pass a head pointer and then data pointer. Initially, sir, current is equal to head. So until current is not equal to none, we are keep on moving. If current dot data is equal to the data whatever you have given, we are going to return true, saying we got the element. Otherwise, what we have to do? Current will become current dot next. At last, we are going to return false. So let us take one example. Sir, I am giving the data field. Okay, I am giving the data field is equal to so 355. The data is equal to 355. Okay, and see the code. Current is equal to initially head. So this one will become current. Okay, so while current is not equal to none, yes. Is the current dot data is equal to data? Yes. Then what will happen? Sir, no. Then what will happen? Current will become current dot next. Is it not equal to null? Yes. So is the data is equal to data? No. Then current is equal to current dot next. Sir, is the data is matched? No. Current is equal to current dot next. Is the data is matched? No. Current is equal to current dot next. Is the data is matched? No. Current is equal to current dot next. Is the data is matched? Yes. It will return true. Suppose if the data is 777, so it is not matched. So it is also not matched. Now current will become which value? Null. Immediately it is going to stop. It will return false. This is the way how to perform which operation? So search operation. Are you clear with this search operation? Please confirm. Let me execute this code, sir. Sorry. So now I'm going to print the list called head. This is the elements. Now I'm applying search operation. Sir, what are the arguments that we have to pass? Head comma the data 999 I am giving. So my expected output is true because that element is there. Now I am calling search of, so head comma I am giving 777. Since this element is not there, it is going to return false. So search is search one. Sorry, we have to take search. Now you can see true and false. Like this, we can able to search for the data. Is this a search operation? Is it clear for you people?
Yes, sir.
Yes, sir.
Right.
Sir, can we use a membership operator in this case?
Sir, which one?
Membership operator.
No. We can't use because membership operators is applicable only for the collections. Is it a collection? We are implementing manually, right?
Yes, sir.
So it won't perform. Okay. Right. So next operation. So if you print the list, we have a list like this. I want to delete the element which is available at the first location. For that, I want to write the code. Okay. So delete at first location. How to delete at first location? I am writing a function like delete at first. I am taking head pointer. So if head is equal to none, then we are going to return none. That means if there is no elements present in the linked list, simply we are going to return none. Otherwise, we are going to return head dot next. Simple code, sir. So here, if you are calling like this, then what will happen? So is head is equal to none in this? No, head is not equal to none. So head is not equal to none. Sir, if head is not equal to none, then what is the instruction that we have? We have to return head dot next. So head dot next means what? This node. This node will be returned. That means what? This will become head. Automatically, this total link will be deleted. Because we are returning this value to the head node. So head node will be updated with 311. If you want, you can see. Now I am going to print the list by passing head. After that, head is equal to delete. Okay, delete at first I am going to pass head. After that, I want to print the list. Definitely, the element which is available at the beginning will be deleted. If you want, you can see. Sir, 666 is there at very beginning. Now 666 is not there. So have you got the clarity about this? Please confirm.
Yes, sir.
Right. Now we will see how to perform delete at last. So delete at last. I want to delete the element present at last location. So delete at last I am taking. So where it is taking head pointer. So if head is equal to none, as usual, right? First case. If head is equal to none, then we are going to return none. So otherwise what we have to do, as usual, your current node will become head. So until your current node dot next is not equal to none, we are taking current node is equal to current node dot next. Like this we are going to move. Let us parallelly explain with the help of example. So this is the current node, right? Initially, is it equal to head is equal to none? No. Is current node next node to next node? That means current node next node is 322, its next node is 333. Is it equal to none? No. So then what will happen? Current node will become current node dot next. Current node next node is equal to none? No. It will stop here. Current node next node is equal to none? No. It will move here. Current node next node is equal to none? No. It will move here. Current node next node is equal to none? Yes. It will stop here. Now we are ready to delete this element. Sir, how to delete that? Simply we can able to write one statement like current dot next is equal to none. After that, return that head. So means what? This is the current node, right? It's a next field. I am assigning to which value? None. So this will become none. So automatically this link got deleted. This is the way how to delete the element at the last location. Let us run this code. Sir, same program I am taking. I am printing the list and delete at last I am taking. And you can see what is the last element? 3. That element got removed. This is the way how to perform delete at first and delete at last. Any doubt on this linked list delete operation? Please confirm. Okay, sir, please confirm everyone. Clear up to this?
Yes, sir.
Yes, sir.
Right. So practice up to this. So remaining things anyway we will continue in the next class. Okay, remaining things we will continue in the next class. Tomorrow we have a session as usual. Tomorrow we have a session as usual. Okay, at 6 o'clock. Okay, 6 o'clock. I will take this particular session. Okay. Right. Thank you. I will upload this within few minutes. This running notes I will upload within few minutes. You will get this PDF document. Okay. Thank you, guys.